Hi guys, how do we solve for a and b in this simultaneous equation? A plus b equals to 6, ab equal to 36. Let's call this equation 1 and let us call this equation 2. So from equation 1, we have a plus b equal to 6. If we move b to the right hand side, we simply have a equal to 6 minus b. Now, the next thing for us to do is to replace this particular a in equation 2 with 6 minus b. So doing that, we have 6 minus b times b equal to 36. Let's continue. 6 times b, that is 6b, minus b times b, that is minus b squared, equal to 36. This means that. Now, let us rearrange this equation. Doing that, we're going to have b squared minus 6b plus 36 equal to 0. You will see that this is a quadratic equation and we can solve it using completing the square method. So let us solve this using completing the square method. So we have b squared minus 6b. So the first thing we are going to do is to transfer this 36 to the right hand side. So this is equal to minus 36. Let's continue. Now let us add half of the coefficient of b and at the same time square it to both sides. The coefficient of b is minus 6. So half of it will be minus 6 divided by 2. And we are going to square it. So we are going to add minus 6 over 2 all square to both sides. So that's the second step in completing the square method. So doing that, we're going to have b square minus 6b plus minus 6 over 2 all squared equal to the right hand side minus 36 plus this again minus 6 over 2 all squared. Let's continue. Now, to combine this guy, we're going to write b minus 6 over 2 all squared. That is, when you expand this, you will have this left hand side back. This equal to minus 36 plus minus 6 over 2 all squared. Let's continue. This means that we have b minus 6 divided by 2, that is 3 all squared, equal to minus 36 plus minus 6 divided by 2, that is also minus 3 all squared. Let's continue. This implies that b minus 3 all squared is equal to minus 36 plus minus 3 all squared, that is 9. So we have b minus 3 all squared equal to minus 36 plus 9, that is negative 27. Let's continue. Now, let us take square root of both sides. So that will be square root of b minus 3 all squared equal to plus or minus square root of minus 27. Because this is a constant, this implies that clearly this bigger square root takes care of this power. We are left with b minus 3 equal to plus or minus. We can rewrite square root of minus 27 as Oh, let's continue. So we have square root of negative 1. This means that b minus 3 is equal to plus or minus square root of 27. Don't forget, from the complex number, we know that square root of minus 1 is equals to I. So we are going to replace this square root of minus 1 with I. So we have I here. Let's continue. This implies that b minus 3 is equal to plus or minus square root of 27 could be written as square root of 9 times square root of 3 times I. This implies that b minus 3 is equal to plus or minus. What is square root of 9? That is simply 3 times square root of 3I. This implies that b is equal to 3 plus or minus 3 times square root of 3I. So this in terms gives b is equal to 3 plus 3 root 3I, or b is equals to 3 minus 3 root 3I. You will see that we have two values for b. We can then use these two values to obtain the value of a. So since a is equals to 6 minus b, let me show you where we got this from. It's from this line. Let's continue. We now have to consider each value of b. So consider this guy first. When b is equals to 3 plus 3 root 3I, so we have to plug it here. We have a equal to 6 minus, in place of b, we write this 3 plus 3 root 3I. This in turn gives a equal to 6 minus times 3, that is minus 3, minus times 3 root 3I, that is minus 3 root 3I. So a equal to 6 minus 3, that is 3 minus 3 root 3I. Thus, the first solution, a comma b, is equal to, what is a? A is 3 minus 3 root 3I, 3 minus 3 root 3I, comma, and the value of b is 3 plus 3 root 3I, 3 plus 3 root 3I. This is the first solution. The next thing we have to do is to consider the other value of b, which is this guy. So let's manage this side. When b is equals to 3 minus 3 root 3I now, we just have to plug it here into this equation. We have a equal to 6 minus into this 3 minus 3 root 3I. A equal to 6 minus times 3, that is minus 3, minus times minus 3 root 3I, that is plus 3 root 3I. So we have a equal to 6 minus 3, that is 3, plus 3 root 3I. That means the second solution, let's write it here. A comma b is equal to, our a is 3 plus 3 root 3I, 3 plus 3 root 3I, comma, y b is what? B is 3 minus 3 root 3I, 3 minus 3 root 3I. So these are the two solutions for this simultaneous equation. Now let's verify if these solutions are correct. So verify. We can use equation 1 to verify it, which is a plus b equal to 6. Let's verify this first solution. So this is our a, y this is b. We just have to plug it into this left hand side. So doing that, we have 3 minus 3 root 3I plus b is 3 plus 3 root 3i. This is equal to, clearly, minus 3 root 3i plus 3 root 3i goes, we are left with 3 plus 3, which is 6. This is exactly what we have on the right hand side of this equation. That means the first solution is correct. Let's verify the second solution. Similarly, this is our A, while this is B. So plugging it into this expression, we have 3 plus 3 root 3i plus, in place of B, we write this 3 minus 3 root 3i equal to, so let's add them together. Clearly, 3 root 3i minus 3 root 3i, that is 0. 3 plus 3, that is simply 6. This is also exactly what we have on the right hand side of this equation. That indicates the second solution is also correct. That's it for this video. Thank you so much, guys, for joining this live session. Please share your tips. Please tell me if this video was helpful, and don't forget to like and subscribe to my channel. I would love to see you in my other videos as well. Have a good one.